Hey everybody, this is week 3 of the web server development class, ASP.NET MVC. This podcast or videocast is going to cover chapter 4, which is essential language features, and we're basically going to talk through some concepts. We're going to talk about a few really C# specific concepts, such as properties, different ways to initialize objects, different ways to initialize collections, extension methods, lambda expressions, the concept of reference type or type inferences using the var statement, and then language integrated query or link. So we're going to kind of cover all those concepts in this video. Alright, so to start out, I'm going to take, or rather I have a empty project, brand new MVC project that really doesn't have anything, no controllers, there's no real views in here at this point, no models. I'm going to start off by building a model, so add new, and I'm going to add a class. And this class I'm going to call, we'll call it a shopping cart. Okay, so we have a shopping cart class. This class represents a shopping cart with items awaiting purchase. So with this we're going to have certain things. We'll probably have some kind of a collection of items, so I'm just going to make a generic array of items for now. And we'll have a float, which is the total price, and those will be kind of the basic fields, and then we'll probably have some methods to add items, remove items, maybe a listing of items. But specifically I just want to kind of cover this concept of a property. So with these fields, the items and the total price, they're private fields. We could make them public, but we lose the ability to kind of wrap these fields into a piece of functionality, a method, or a routine of validation, and really it's a concept of abstraction. So what it allows us to do is if we actually create a property, we can say public array items, and then we can set our getters and setters inside of here. So we can do return items, and then we can say underscore items equals value. With this, I'm just going to create a method here real fast. So we'll say public void add, and we'll take in an object which will be an item. We can then say items dot add. Actually, let's make this an array list. Make this an array list as well. And then we can add the item. So by doing this, we've now made it so that the items field is separate or hidden from the property items. It's decoupled is really the term. So let's go ahead and add another class, and maybe we can show this in a different way. So we'll make an item class. So now the item was going to have things like a name. It will probably have a product ID and a float for price. Now again, we can set up properties for these private fields, and we can return name, and we can say that name equals value. And value is a specialized keyword that basically takes whatever is on the assigning side and it gets stored in this temporary keyword called value, and then you can pass it into your field. Let's say with the name we want to actually make it more unique. We don't want it just to be the name. We decide we want it to be product ID : name. we can actually do a modification here. And whenever in our code we call the item.name property, it'll actually take the product ID and the product name and concatenate them together. So we get some real functionality there that we wouldn't get necessarily by calling these fields independently. So properties on a whole are this way of kind of abstracting from the actual local variable versus what is accessible publicly to your own code or to other segments of code, and it gives you some flexibility where if you have to make a change of how a piece of property works or how a piece of data is accessed, you don't have to deal with those fields directly and make a very large change. You can change the inner workings of these properties and make them function in different ways without affecting the interface or the property itself and how it interfaces with other pieces of code. Alright, so in a nutshell, that's how you set up properties. So hopefully that should be familiar to you from your C# class, but if for some reason you're a little rusty or maybe you were still a little lost, that'll help clarify that for you. So I'm going to set up two more properties here. So we'll do public string product ID, and then we'll return product ID, and we will say product ID equals value. And then there's actually a shorthand notation as well where you can do this. I typed prop double tab and that brought up this snippet for me. I can say this is a float and this float is the price. By doing that, I can actually drop this private field completely, and what C# does is it generates internal private variables on compile time. It looks at this and it says, okay, I need to create a private variable in memory to hold the price, and then these getters and setters just do this basic functionality of taking whatever that value is and returning it, or taking the assigning value and storing it. So this is actually a nice little shorthand. Again, this does not remove the ability for you to change the inner workings here. If we wanted to actually convert it from the shorthand to the longer notation, we can just change these gets and sets internally and make them, get and set. Create a private float and then say return price equals value. So it's really that simple to convert it from one way to the other. I'll be honest, the shorthand is nice. You don't have to think so much, and when you're doing real basic assignments, there's no need to bother yourself with this code or get yourself lost with a lot of additional private variables and public properties. So if you can simplify things when possible, I recommend it. Alright, so I'm going to make a couple of adjustments here. We'll make this a list of item, and then we will have, this will actually be a dynamic property. This will be a list of item as well, and we will no longer need a setter. So I'm going to add a constructor. Shorthand is CTOR, double tab, gives you a snippet for the constructor. And we were going to say items equals, underscore items equals a new list of item. And I'll just put a summary note here, so these are items loaded in the cart. Alright. We can take this from object and call it an item now, making it strongly typed. And then we can add public void remove, and maybe we'll do it by item as well. And we can say items.remove item. We won't need a listing of items because we can get that from our items property. Okay, so inside, let's go ahead and make a controller, add new controller. We'll make this our home controller. And let's do a little bit of work with our shopping cart and our item class. So let's start off with maybe creating a list of all of our items. So we're going to need a repository inside of our models, and we'll call this the item repository. And this is just going to have one method that will return available items. Now normally this method would it would probably connect to a database, and it would retrieve items as records and then load the record data into the item objects and then return an array of items. For us though, we're not going to go through that much work for this example. What we're going to do instead is we're going to just initialize an array of objects. Now, to initialize, we actually did not set up in the items a constructor at all. There's no constructor in here. So what we would traditionally do is do a CTOR item, and then we would probably do something like string name, string product ID, float price, and then we'd have to go through and say name equals name, and so forth. So we could still do that, but let's say we chose not to, and then on the fly we go, oh, we need to create an item. There is a new, in .NET 4, there is a new initialization option where you can say item, and we'll just call our variable item1 equals new item, and then not using the parentheses but using the curly bracket, we can actually, and I did control spacebar to get that IntelliSense pop up, it actually gives us access to every property of the item class that's public. I can then say name equals orange, comma, product ID equals O, R, G, comma, and then price equals let's see, 0.99. Semicolon after the curly bracket, F for float. And what this has now done is it created an instance of item, and then it actually, this snippet of code in the middle does a item1.name equals orange, item1.product ID equals ORG, item1.price equals 99 cents. All this one block of code does all of that for you. We can also do this within an array. So let's say that we need to declare our array of item. So we'll call this the item collection. We could initialize this collection using a similar notation. We say new, and then inside of here we just start creating new items. So we can say new item, and we're not so concerned about item 1, item 2. We'll just say new item, open curly brace, and we can say name equals orange, product ID equals O, price equals 99 cents, comma, new item, name equals apple, product ID equals A, price equals 87 cents, comma, and we can repeat this over and over again. So we're actually initializing the array of item using the short notation of new, square bracket, and then curly brackets, and then inside of the curly brackets we're actually adding items. And then inside, instead of actually having predefined a bunch of items, and let me just do this for clarification as well, we could start this off with item 1 and then continue on. We're actually using, again, the inline notation for initializing an object as well. So we're getting all of that accomplished right inside the declaration, instead of having to declare a bunch of items, then create a collection, and then set the value of each position in the collection to one of those items. So we can just make these adjustments, 50. And last step is return the item collection. Okay. So we'll initialize a new item. initialize a collection, and then return collection. Alright. So inside of here we can then say item, we'll call this available items equals, I need to make my item repository method static, so we'll say this is a public static. So we'll say available items equals item repository dot available items, which will return to us the collection. And then we'll create a shopping cart equals new shopping cart, and we'll say cart dot items add, and then maybe we'll just take the first item off of available items. It will do the first 3 items, 1 and 2. Now let's say that our cart doesn't actually have a method to get total. For whatever reason there was no method built, and the shorthand to do it, or the easy way to do it, is we would basically declare float total price, and then we do a for loop and loop across cart.items, and we'd say total price plus equals cart.items I price. Initialize this to 0. And then what that would do for us, items.length.count. So what that'll do is it'll loop through all the items in the cart. It will then take the price and add it to total price, giving us, once it iterates through, giving us the total price. So this isn't terribly complicated, a lot of work, but it would be nice to be able to just call a method get price off of the cart. So one way is to, obviously, since we have access to the shopping cart class, we can go in and add that method. But let's say that this was a library that we downloaded and we just needed that little bit of functionality to make our code cleaner and easier to read. We can actually build what are called extension methods, and what you need to do then is you build a class, and I usually like to label mine as extensions for the name of my class, and this class will be a static class, and inside of it you're going to have static methods. And that'll be the basic mechanics of our method. Now the catch here is that we need to link this method so that it extends the shopping cart class kind of as a relative. Now you could, in normal cases, you would say shopping cart, cart, and that would, you would pass in the cart as a parameter, loop through, and then you return total price. Inside of our code, though, we would actually have to call extensions dot get total, pass in the cart, and then say float total price, and capture it that way. Well, this is doing it without an extension, and that's not what I want. What I want is float total price equals cart.getTotal. To make this syntax work, we go back into our extension and we make a modification to our parameter. We put the word this in front of it. Now, that doesn't change any functionality of this method itself, aside from putting the keyword this in front. This method still looks exactly the same, it functions exactly the same. What this does is that it implies that this method is owned by this class. So when we go back to our home controller, we no longer have the red-blue underlines. It now likes this syntax, it's accepting it. Further, if we drop get total and we do cart dot, we now have a method listed here called get total. You'll notice the IntelliSense, the tooltip pop-up shows it as an extension. The icon for it is a block just like a normal method, but it has an arrow pointing down, and what that signifies is that this method is an extension method. So it's not actually owned by this class, but it lives in a library or a class somewhere else, and by virtue of it quote-unquote owning or extending the shopping cart class, the IntelliSense picks it up and brings it in and says, you can call get total on cart now, because it's an extension that is declared somewhere else and you have access to those extensions. So in our case, it's in our extension class. So extensions are a fun little thing to do, especially if you're maybe running this particular block of code and you're running it against a class that you don't own, or for whatever reason you don't want to modify the code for that method, that class directly, but you want to be able to build these extensions onto that class. You can use it using the extension syntax. So extension methods are really kind of fun little things. Personally, I've done it where I've taken and I've built an extension method for web form controls or WinForm controls, even building extensions for pieces of functionality that I may have written in a different library, and I find that, it'd be nice in this case to be able to do this routine and do it very simply and efficiently when I need to make this call. So I'll build an extension method extending a class from a different library that I had written. So they're definitely useful. One other thing that you can do with extension methods, before I forget, so you can apply extension methods to classes. You can also apply extension methods to interfaces. So if you want to build a more generic extension method that takes any interface, you can do that. The same goes. It's basically, instead of putting a class name here, you put an interface name. So that's fairly self-explanatory. You can also use collections, and you can do limiting or limitations or filtering on those collections. So let's say that we had, instead of a shopping cart, we had IEnumerable item. So we could go through here. I didn't think it would like those. And we can basically do a for each loop. And let's say we want to filter on all product IDs. So we can do a for each item C in cart. Then we can say if C dot product ID equals product ID, yield return C. And then we'll change our return type to be IEnumerable item as well. So this syntax may look a little unusual, and what this is basically saying is loop through all the items in cart, do a for each loop. We then have a logic check. If the product ID equals the product ID that was passed in, then yield return that particular item, C. What the yield is going to do for us is it's going to pick up that C item and it's going to add it to another collection. That collection is dynamically built by the .NET framework and then returned as an IEnumerable type. So if we save that modified extension, this extension no longer works. But we can now say cart.items.get total. So the get total now has been moved to a IEnumerable, a collection, if you want to think of it that way, of item, which is what the items collection is, or the items property on our cart. And then what we pass in is product ID. So it's not asking for two parameters here, it's only asking for one, product ID. But our method actually takes in two. The first one is the collection of item, which is inferred by the fact that there's a list of item here. So that parameter is passed by the framework. The second parameter, product ID, is what we actually have to input here. So we'll say A. And then we can then say IEnumerable item result, and that'll give us back any items in the cart that have a product ID of A. In this case, there would be 2. Okay, so then the next thing that I want to kind of talk about is this idea of type inference. And what type inference does, or provides you the ability to do, is you basically can declare a variable, and instead of giving it a type, you use the keyword var, and let's say var item equals, and we can say just say var item. So now that item can essentially be whatever we want it to be. It's not strongly typed to anything at this point, it's just whatever. So we can say item equals new object. We could say item equals apple. We can say item equals 12. Item equals new item. We can do whatever we want with it. There's no requirements. The trick, though, is that var implies or infers the type based on the initialization statement. So once the value of the variable is initialized on one line, we can't go and say item equals apple. If we attempt to compile, we'll get a complaint. Now actually, that's probably a bad example. What I should have done is this. Recompile. There you go. So you have to initialize on that same line, and what happens is that upon the initialization it actually looks at item here and says, okay, var really needs to be item, so this item variable is of type item. So then if I try to say item equals apple, it's going to say you can't convert a string to an item. So it already made that distinction. So it looked at this and said, oh, this isn't really var, it's item. Now, the var keyword is nice if maybe you don't know what the exact return type is when you call a method. It's also nice when you're just trying to quickly, code up a method to test and troubleshoot. You don't have to worry so much about, coding out those data types when you do your variable declarations, but they're still strongly typed. So once you say var item and then you initialize it, whatever you're initializing to ends up getting inferred in the declaration. So that's something to keep in mind. Alright, so then the last two things, which kind of work hand in hand, I want to talk about is what are called lambda expressions and link. And I talked a little bit about lambda expressions, I think, in week 1 when we went through some of the basic markup for the Razor syntax and how that works and how that looks. I'm going to go through that in a little bit more detail now, and I'm going to show you some extension methods that utilize lambda expressions. I'm then going to show you how those extension methods and those lambda expressions are created, the equivalent, in what's called language integrated query, or link. So to start off, we need a collection to use these particular lambda expressions. Now, what I'm showing you is data manipulation, but there's other ways of using lambda expressions besides data manipulation, but the most kind of obvious or concrete one is using these extension methods. Now, if you're going to do link, or these Lambda extensions, you'll need to make sure that you have the using system.link namespace included. And then you can take any sort of collection, and you can say available items, for example. We say dot, and we get a whole list of all these extension methods. And these extension methods allow us to do different SQL type actions. So we can do a where, we can do a union, we can do a lookup, we can cast things to lists, to dictionaries, to arrays, we can do a sum, we can do singles, we can do select statements, we can do mins and maxes, and these extension methods have built into them the functionality that you need to perform the task, but they're completely dumb to what data you're actually dealing with. So let's say, for example, we have all these available products, and what we really need is, we don't need the whole item. What we just need is a listing of the names. Okay, so we need a string array of product names, and the way that we can pull those product names out is we can say product names equals available items, and then we can do a select. Now, if you look at the IntelliSense pop-up, you'll notice that there's a lot of what almost looks like voodoo in here. What it's going to say to start off, and if we break it down, and hopefully this comes across with my mouse pointer, it says extension IEnumerable T result. So what this is saying is that it's using a generic, and T result, so IEnumerable T result is the return type. Then the method is saying that it's an extension method of IEnumerable T source. Select is the method, and select expects T source and T result. So those are the two generic data types that it's expecting. Then what needs to be passed in is a function that takes in, or that accepts T source, an integer, and returns a result of T result. Okay, so that all sounds pretty complicated. What it really boils down to is that it wants a function that takes in an item and returns something, and that T result is inferred at compile time depending on what you actually return back. So you'll notice it still says IEnumerable T result, IEnumerable item. So it knows that inside of available items is an array of items. So what's going to be coming in is a IEnumerable, a collection of items. And then the function is going to be, it needs to take in an item and return whatever it wants. Now the item that's going to be passed in is, it's looking for a function to pass item into. Okay, so lambda expressions are a shorthand notation for declaring a function. The way that I always like to kind of introduce the concept is a function has parameters, and then it has a body of execution. So if you think of the way a method normally looks, you have public void do work with parameters, and then you have a body of execution. Okay, the equivalent here, and maybe we'll do this, we'll say item I. The equivalent in a lambda expression is I work to do. Okay, these are in theory equivalent methods. The trick now is inside of here where the work to do is, what do we want to be selecting from the item? In order for us to get product names, we want to select the name of the product. So we'll say I dot name. Let me change this to IEnumerable. Okay. So that then gives us, so if we look back at our select again, our IntelliSense, it now says that it takes in a function that takes an item and returns a string. It infers the string from the name property, which is a string. Alright, so this is the equivalent of this. If I wanted to, I could put in here do work. And it would be perfectly happy with that. It would then call do work, pass in item I, and return a string. But having to go in and declare a function every time, or let's say I wanted to nest these together and say where is product ID A, I have to do public bool is product ID A, item I, return I dot product ID equals A. It's a lot of work every time. Or it's just a lot of code, I should say. It's not work. And then you have to figure out what is product ID A. You have to scroll down and find that method, do work, same thing. So the Lambda expressions allow you to take this method and bring it up into the call. So to do that, the even shorter hand, if we do work again, was I arrow return I.name. Since we're only taking in one parameter, we can drop the parentheses. The arrow says these are params, this is the action. We can also drop the curly brackets, and when we drop the curly brackets, we can drop the return. So what this now becomes, and we also can drop that. So this in between the parentheses becomes our Lambda expression. So I is item, and the work that's to be done is to take I and return I.name. With the where statement, we can do the same thing. And we can say I.product ID equals A. That's it. No need for the methods below. And if you're wondering what where does, where takes in an item and returns a boolean. So it's going to take that item, it's going to evaluate I.product ID equals A, and then whether that's true or false, that will get returned back from the Lambda expression. The where statement then uses that boolean to decide whether or not that item I should be included in the result collection. So that's basically doing a filter. It's only returning items that have a product ID of A. Then from those items, which in our case there's 2 of them, it's then going to select the name of those products or those items and return, the select statement is going to return an IEnumerable of strings. Now originally I had this set up as an array. There's one more extension method that we can say .toArray, which will take the IEnumerable and convert it into an array. So these three extension methods utilizing Lambda expressions allow us to take all the available items. We can filter by product ID. We can select just the name, and then return or convert the result set into an array. So we could have done all that work, the traditional way, but we'd have to create an array we'd have to go through and do a series of for each loops and select statements and converting lists to arrays depending on the size, and there's just a fair bit of work that would be involved in doing all of that, where this does it in 3 steps. So lambda expressions are very powerful, especially when you're using these extension methods to help you. Now you'll see these extension methods a lot when you get into the Razor syntax. They're used when you're pulling stuff from models. They're used when you're using the HTML helpers. So it's a lot of good stuff in these lambda expressions just to help facilitate that work and make the code easier to read once you understand them, and makes it a little more user-friendly. Alright, so the last thing that I want to show you is really just the equivalent. So this is a lambda using what I kind of call link methods. But you can also create an actual link statement. You can say product names equals, and then this is link. And you would say from F, or from I, in available items, where I dot equals a, select I dot name. And I'm going to wrap this up in parentheses and call to array. So the lambda expression above using link and the link statement below are completely equivalent to one another. They're just different syntactically. Now I was first introduced to link, and I thought it was very, if you're familiar at all with SQL, T-SQL, SQL Server, Microsoft SQL Server, or Access, you're like, it kind of looks like SQL, but it's not exactly like SQL, which is correct. And the syntax is a little awkward, but not that strange. And I found it a little cumbersome to use at first, but I got very comfortable with it over time. Then I actually learned about the lambda and using the link methods, and I personally find that, just because I'm more familiar with programming, I find those to be much easier to read. They just seem to click or make more sense to me. The from I in available items specifically, it's just strange. It is what it is. Where when you know that you have available items and you have this lambda expression and I is the name of the variable that you're declaring, you know kind of where that all derives from and how it all fits together, so it just seems a little tighter. And then if you end up with really complex selections where maybe you're selecting a sub item and then you're doing another selection underneath that, when you start doing those things in a link, they get very hairy and hard to read, where doing them with the link methods and lambda expressions, they're very clear cut. You have one step at a time, and you're not trying to reference things that are out of scope, and you can run into that a lot with link. So that's just from experience. Your experiences may differ. Your mileage may vary, but it is what it is. So those are lambda and those are link. Now, some things that I have seen that can come in very handy is your use of type inference coupled with link and lambda. I've seen where instead of declaring this string array of product names, you would just say var product names and then not bother dealing with the cast to array. So when you have something like this, and I'll just comment this out, you can then say product names, and what you have is actually an IEnumerable of strings. So now you have some pros and cons to this. When you have an IEnumerable type, you do not have access to the indexer. You can't say 0 here. You can only do that with things that have indexes. But things that are enumerable, they work perfectly inside of for each loops. So again, within the for each loop, you could say var name in product names, and things start to get really abstract, and then you could work to do a like a print Now, obviously we're in a web app, so that's not going to work, but you could then, print the name. So you have that ability to do those types of things without really strongly typing anything. They are strongly typed because they're inferred types, but you're not worrying or getting yourself all wrapped up on, well, what type is name, what type is product names. You know that product names is a collection. You know that name is something that you're interfacing or interacting with, but you're not caring so much about what exactly are they. Things can get even more interesting when you want to create custom anonymous types. You could go in here and say new curly bracket name equals name, comma, cost equals i.price. So what's now happened is that when you do your select, it's taking the item, it's creating a new, what's called an anonymous type, and this is basically the property and the value, property and value. So when you get down here into name, what's happening is that product names is now not a collection of strings, but it's a collection of this anonymous type A, if you notice in the pop-up. So that means that every item, and I'll call this I, or I'll call this item. So every item in here is of type A, anonymous, and that type has two properties, cost and name. So you can do a lot of interesting data manipulation using LINQ and Lambda and your anonymous types coupled with your vars, with your inferred types. So you have a lot of power, and you also have a great opportunity to get yourself very confused. So walk slowly through some of this as you're wanting to explore it. There's a lot of good things here, but also things that you can get lost in. I've gotten myself so turned around, sometimes I have to go back to paper and pencil as I'm going through trying to code some of this stuff, just to make sure that I'm understanding what I'm trying to accomplish, because my variable names and my methods and my filters and just so much of it starts to get a little overwhelming, and you have to break pieces into chunks and make sure that you're doing it step by step correctly, and just not totally losing sight of what you're trying to accomplish because you're so wrapped up in, does this exist and where did it go and what am I filtering and what does I really mean. So those are things just to kind of keep in mind as you walk through this. Again, it's a lot of good stuff. It's just, tread softly, carry a big stick, and just kind of, pace yourself as you're going through this stuff, because it can get a little crazy quickly if you're not using good, strong variable names, just calling everything I and J and so forth. So, alright, so that is chapter 4 from the book. One other topic that chapter 4 does touch on, and I'm not going to get into in this lecture, I'm going to wait until we get to chapter 17, is the concept of async methods. And the idea is that you can run code asynchronously. You have the ability to run multiple processes. You have the ability to create multiple execution threads where you can run different pieces of code out of process and have them run and then have them return back or call back when they're done. And you see that a lot with your web browser, for example. Your web browser itself is a window. When you go to call up a web page, the web browser doesn't stop working while it's going to fetch that web page. It actually spins up a secondary process to go out and fetch the website and then bring it back and render it. You can do those same kinds of things if you have very complex tasks on your web pages, or even if you're doing a win form. The thing that gets very cumbersome is that you have this request response type action going on, where you invoke or start a process and then you wait for that process to end and then call back and say, hey, I'm done. It can be done. The .NET framework up to this point has done a great job of trying to simplify that, but it's still not perfect. You still have to create secondary callback methods or Lambda expressions to handle those callbacks, and you just end up with a lot of extra code that is, out of the box, should be very routine. With C# 5, which was introduced in .NET 4.5, you actually get the ability to create these async methods, and you're utilizing two keywords that are async and await. And when you have an async method, you can then use the await keyword that allows you to call the async method, and then you basically you're telling the compiler and you're telling the runtime, run this line, it's going to run asynchronously and wait. Just stop execution and wait for it to finish. You don't have to write a callback, you don't have to do a lot of extra work. You basically tell it, run this code, it's going to go do something, and just wait for it. And the await will actually stop execution, it'll hold on, and then the line of code itself is very simplistic. It looks like you're just doing a straight method call. You're not calling out of process or calling on a separate thread. It returns back the value, and then you move on your way and do what you need to do. So it's very slick, it's very interesting piece of functionality. Having at least a basic understanding of multi-threaded apps is probably a good thing, and that's why I want to kind of hold off to cover this, is I want to at least give you a bit more of a primer on what multi-threaded apps really look like, because not understanding the mechanics can really just send you down a really dangerous path, and you could end up spinning up processes that you lost track of or lost ownership of, and it can honestly turn into a bit of a mess. So I want to wait to kind of cover that later in the book and as we have time permit. So that is chapter 4 in a nutshell. Hopefully you've not been bored to tears. Again, first webcast. I hope that this is useful. You can go back, rewind, review. As always, if you have any questions, please feel free to email me. We can set up a Skype session and so forth. Alright, thank you very much.